Beyond Now Expert Talk by Siemens.
Hello to Beyond Now, and today's topic is the next step to resilient supply chain, the power of additive manufacturing. And I have the pleasure that I have two fantastic experts for additive manufacturing in the show. It's Ari, head of new business at Mercedes-Benz, and Carsten, head of additive manufacturing at Siemens. Welcome.
Thank you.
Thank you.
Hello.
So, gentlemen, it's really a pleasure to have you in the show. And as everybody can see, the title of the show is Beyond Now. So we are talking about what will be the next thing after the current situation. And you are all in home office. And well, I mean, if we have a look at the past months or even past weeks, this was really, to me, I mean, beside all that it's exceptional, it was also fantastic to see how additive manufacturing or 3D printing was just contributing to solve the COVID crisis on a certain level. It was on a really early stage of the crisis where I remember that a lot of my friends from the maker scene were just pushing in. They were helping people, hospitals in Italy, from Germany or in France on a collaboration way to build 3D printing parts for face shields and ventilators, which was a fantastic experience to me because everybody was talking about additive manufacturing at this point, and it was really helpful. So what we have seen is like, to me, has this been a turning point in the public awareness of that additive manufacturing is here? It's a real worthful technology we can even use for critical items. And this is my question to you, Carsten. What was your view on the situation, and how have you seen this as an additive manufacturing expert?
Yeah, thank you, Mirko. So if we look back what happened in March, and similar to you, I'm sitting in home office and working from home since mid of March. And I still remember the week. It was around March 10. The first announcements popped up that makerspaces started to print valves for ventilators in Italy. Even the European Union made a call for additive manufacturing parts in the world. Immediately, we teamed up within Siemens. As you know, we have more than 200 printers in a Siemens-wide company core technology field. So we teamed up with a well-organized network within Siemens. And 1 week later, I talked to my colleague, Robert Meschel, who's heading the AM network in Israel. And he as well started to work within a week with his team to open up this collaborative platform to connect supplier and demand and hospitals and service provider with each other. I think I called Ari in the same week and talked to the Mercedes-Benz. I talked to EOS, HP, the machine builder. So everybody, and the dynamic was awesome. So the AM community stood up within, I would say, 1 week worldwide, working together, connecting through all the digital platforms.
And to me, it's something like a disruption in the health sector. Because keep in mind, health sector is, let's say, pretty conservative in the way how to develop products and how to introduce products. But in this particular case where it was about life and death, people were trusting their life towards parts who have been produced by additive manufacturing. Have we now increased trust on additive manufacturing and 3D printing? What do you think, Ari?
Yeah, Mirko, I totally agree to what Carsten just said and to your notion. I was also very elated to see the developments which the additive community was doing worldwide. And as Carsten mentioned, similar approaches came to me as well from within Daimler, because we also own a big set of additive manufacturing hardware distributed among different places in our company. But to answer your question, let's take a step back. A step back to the history. History has always shown that when there is a time of crisis for mankind, technologies have accelerated. technologies have gained acceptance. And this was no different in this case of COVID, because it was a time of crisis. Global supply chain was disrupted. People were looking for ways to create parts for medical help. And that showed people going to new technologies, trusting new technologies like additive manufacturing. And I believe that it is a very positive development for the technology, which used to exist as a niche always, but now has transitioned into the mainstream media with people talking about it, with the presidents of the country talking about it, and our health workers, health organizations certifying these parts and using these parts to save life of people. So I believe that the trust of the technology has definitely increased many folds due to this crisis.
So, yes, I think it was awesome. Really, watching all these people worldwide working together, and keep in mind the short time frame they were setting themselves for their projects. I mean, this was amazing. Worldwide collaboration, let's say an agile approach on engineering towards production. So this was COVID. Now, I mean, a couple of weeks are past, months. The situation, luckily for us, is more stable now. So, and we can think about now the next steps. What is beyond? So, Carsten, to me, the big question will be, okay, looking back from the lessons learned now, what are the, or what was the initial game changer we now have seen, or is it really a game changer we now have seen if we look forward towards industrial production?
If you compare additive with classical traditional CNC milling, additive is still a tiny and a small part.
Mm-hmm.
The pattern of these kind of startup communities is always very tight collaboration. People are helping each other to bring additive into an industrial scale. This was the case before and during COVID, and for sure I'm pretty convinced that this will be the same kind of collaboration in the future. Just to give you some examples. A printing machine itself is not worth its price if you don't have good software bionic designs and applications. If you have a good software and at the end you have the perfect bionic design with improved performance, but the machine itself is not doing the job on productivity, on reliability and quality, this does not work. Therefore, I think this is a tight collaboration we have in place, and we need to proceed now because we have some homework to do. It's about getting this industrial scale. It's about getting productivity up, costs down. It's about developing a lot of engineers in the software tools, how to produce and how to design for additive. And this needs to be hand in hand.
So as you have mentioned Mercedes, and we all know about the complexity of car production and all the things around. So, I mean, it's a good question to you, Ari. Now, let's talk about how do you use additive manufacturing at Mercedes-Benz?
So at Mercedes-Benz, we have a long history of applying the latest and the pioneering technologies into our day-to-day work, into our products. And that was no different for additive manufacturing as well. So we have been working with additive manufacturing for many decades now, in fact, and it started with just using it for building prototype of parts to have a look at, transitioning to prototypes which were then fitted in test vehicles and driven around, including powertrains and other components. And now we have transitioned even the next step to go into non-productive materials. So in Germany, in the production facilities, you have a lot of helping gadgets and helping tools in the production. Those are very specific to the components. Those are very specific to a particular car, and those can be ideally done with using technologies like additive manufacturing, and we are extensively using it. In fact, the next step or the major breakthrough for us is actually going from these non-productive parts to parts in a car, and we have done that. We have done that in the past, especially for vehicles of our old-timers, so classic cars where the parts are not available on the market. So we use this novel technology for creating spare parts, and thanks to all the development which has happened, the quality of the print, the quality of the build has come to a standard which can be accepted in many cases, also for the automotive industry. And we reap the benefits of additive manufacturing, especially with its ability to print one-off part, to have small batches, to give our customer the freedom of individualization and thereby making the car their own. And those are some of the primary benefits combined with one thing, and that is a global distributed manufacturing possibility. So we don't have to make all the parts at one place and distribute it across the world. We can print it, we can generate it at places where they are. I mean, these are also still some of the visions which we have, and I think these are also paths which we are following. Certainly, there are challenges as to everything. I mean, before we can make it really into mainstream and use it in a day-to-day basis, we need to work on the process stability. We need to work on the traceability of the parts and certifications and so on.
Which is a good point, just Ari, because I know that car manufacturers are, let's say, rather passionate on quality. I mean, you're rather focused on quality, and it's completely different, let's say, to look on quality on additive manufacturing, because, you know, different printers, maybe there are variations in parts. How do you deal with that inside your organization?
So you rightly mentioned, we have very strict quality standards and codes, because when you are sitting in an iron box which is moving at 200 kilometers per hour, you want it to be safe. Yeah. And that's our primary focus. That's why we have high quality standards. And we are working constantly with our R&D guys, starting from understanding the material to the printing processes with the print manufacturers to understand the process stability in order to define maybe the new way of thinking how to qualify a 3D printed part, because we have to make changes here. The classical process of qualifying parts or suppliers might not apply for additive manufacturing. And that is where Mercedes-Benz is working very extensively together with the partners in order to develop those standards, to develop those, the processes, how we can ensure quality, because we don't want to compromise on that. And secondly, we are also working a lot with our development engineering guys who are designing the parts for additive manufacturing, because that is also a big mindset change which this technology requires. And this technology actually provides the opportunity to maybe think differently, create parts differently.
Which is a perfect question for Carsten, I think so, because we have learned now additive manufacturing is not only about printing. It's about process, it's about collaboration, it's about digital transformation, all included in a completely production chain or engineering chain. So what kind of digital processes are needed from your perspective, and even what kind of, tools you need to successfully implement then additive manufacturing?
Yeah, the tools and the processes once more follows the requirements like Ari mentioned from the manufacturer. So just give you some examples. If you look in tooling spare parts, in this area, it's of utmost importance how fast are you in designing, automated and printing. It's not so much about bionic designs in this area. So there, for this distributed manufacturing, you need digital tools to manage this process. There, for example, Siemens has the AM network, where you can design a part, you can upload it in location A, and then you transfer it through a digital marketplace platform somewhere to South Africa or to South America or to Asia to print it locally. So these are digital tools to manage, for example, the use case Ari mentioned around spare parts, print where you need it and when you need it. Mm-hmm. If you're looking in the value chain of serial parts, where you really come to the leveraging of the importance of additive manufacturing, which could be lower weight, which could be better flow, better cooling, then it's of utmost importance to have what we call the digital twins in the early process chain, which allows you, for example, in terms of generative engineering, to design by software instead of manually designing the part towards the best process flow to the best cooling behavior, and then you come up with these crazy structures. And then further in the process, you need to seamless integrated digital tools because you want to simulate before you print. And this is a task for first-time write printing. So a machine time is very expensive, and therefore, whatever you can simulate, distortion, optimizing in the process is something which is used in a digital tool. We call it digital twin of the process. And then, as Ari mentioned, if you print a part, you have the quality assurance in the machine. So you can now use digital tools like edge computing, like clouds, to monitor process layer by layer, by images, by other possibilities. So there, the tools are helping you to qualify the process and the reliability.
But no, not a but. I would say it sounds always amazing that you have all this big data stuff now. I mean, you're getting ability out of data because it's a digital process. So you're collecting a lot of data even for each production part. I mean, for a single part, you have a digital twin for a single part. This is more data than ever you have on a part production. Okay, completely understood. There's a huge opportunity out there. But however, it's always a question, you have the data, who are the right partners you can use to really leverage out of the data? Because having the data is nice, but it's not that's not the rocket science in behind. So Ari, how do you collaborate with partners then to really leverage this advantages out of the new digital data models you're getting? And for example, how do you work with a partner like Siemens? What is your approach there then on collaboration? And even like, let me one sentence as well, because I know as well that car manufacturers are also rather aware on keeping the data, let's say, inside their Control, exactly.
Yeah. Add to this point what Carsten just mentioned. Traceability is very important. Having seamless data and is very important for us, because what we want to have is a complete understanding of the life cycle of any part, because in case of anything happening in service or to understand and improve on the quality of any part, we need to understand the entire process of inception to usage. Yeah, and there we believe that digital and seamless digital platforms could be and are already very, very vital for us. And we are working there with Siemens a lot, because as some of you might know, that Siemens provides excellent CAD system, NX, which is being extensively used at Daimler. So we are generating parts over there. And then there are always software add-ons available, which help us to design parts for additive, making checks which are essential for producing good quality of additive manufactured parts. So that is the part where the inception and design takes place, and then taking this digital data, taking it to the printer, following it through the print process, and thereby having a whole life history of the parts, even though it might be not required all the time, but to have it and have some sort of a digital fingerprint of each part which has been produced, so that we can ensure and tell our customers that that during the entire process of development and manufacturing, we have ensured the best and the highest quality. So that is where we see that there is a need of a lot of digital collaborative platforms. And we are also working extensively with various digital collaborative platforms, some of them also from Siemens. And we believe that this is essential also to make success of this technology in the future.
But coming
Does that answer your question?
Yes, yes. From your side, yes. But of course, I have a couple of more questions popping up, because I think, yeah, data, great. And then I think of the people who, from the other side who say, yeah, data, great. We can encrypt it, can put ransomware on it, or we can steal it, we can copy it. I mean, there are so many things with the digital data models which are related to security and to safety.
Absolutely.
So the question to Carsten, which is not an easy question, I think so. Yes, I mean, what is needed to provide this kind of quality assurance, like fingerprinting, sounds great to me, and safety and security inside the additive manufacturing space?
Let me try to split it in two aspects, this answer. First aspect is the 3D file of the part itself. If you consider you have a warehouse, spare part warehouse, you always have a fence around it, and you make sure that nobody can steal your parts and can rebuild your parts. Now consider, as Ari mentioned, and the same happens in Siemens Energy for gas turbine, it happens in Siemens Mobility for trains. We are now having digital spare part marketplaces. And there you store your 3D printed part, and you still are responsible and liable for the part at the end. And now you upload it somewhere. And this is what we are working a lot with, a lot of experts and know-how into this. And you want to print it because you need a spare part for a certain train in South Africa. So you need now to have this 3D printed file transferred from somewhere in the cloud securely throughout the world. And then a new layer of digital questions come up, how to transfer it, how to make sure that nobody is getting the file out of the loop, is corrupting it, bringing it up, because you're still responsible at the part if it's printed. And then the third question, if now you have a certified service provider in this country, how to make sure that the part you qualified once in your home factory has the same quality if he's producing it. And there we come to this digital fingerprint we just started to discuss, that with additive you have the unique opportunity to monitor process by process. For sure, you're sending with the 3D file process requirements, which machine, which material, which temperature, all this comes with these. But you need to make sure that the service provider is always following the certification, because at the end, Mercedes-Benz or an aerospace company is responsible that the part stays to the quality as certified in the application. And now the possibility once more is to take this monitoring data, and yeah, you already mentioned, it's tons of data, and the data are not easy to find the ways, what's now a good digital point and what's a bad point. So you need a lot of teaching of this system. You need artificial intelligence algorithms after a certain time. For example, if you take images where you have grayscales of one layer, you need to teach your software that a certain grayscale might be a problem. Another part might be a good grayscale, and that you teach these software systems, because storing the data is not of any value. It's about learning from this, further teaching your software algorithms to come better and better, that at the end you can really trust these data, these fingerprints, as a quality assurance. And there we are just at the very beginning.
But it shows as well that it's not only we're talking about technology, okay, additive manufacturing, but we are talking as well on a huge part on changing processes or for quality management. If I remember, Ari, PPAP in the automotive industry, I mean, this is a big standardization framework for quality management made for batch size, let's say 100,000 plus parts. I think it's so complicated to redesign the processes in an entire organization to say, well, now batch size 1 is fitting in there, and of course there are different conditions from different 3D printing vendors, machines, and stuff like that. So, is it challenging? Yes.
Yeah, I mean, here's the thing. I mean, we are not only changing and evolving processes. I think we also require some sort of a rethinking of some of the processes, because you need to understand processes are created in order to stabilize certain aspects and steps of working. And if the working way changes completely, which is in case of an additive manufacturing, which is in case of the supply chain of an additive manufacturing, then we need to rethink. And I think the industry is going through that. I mean, as Carsten mentioned, there are so many initiatives on it. We at Andor are doing a lot of initiatives. We are working very closely with our procurement departments to understand how you compare, how you define the what you can say standards for additive manufacturing supplier as compared to someone who is supplying injection molding parts. And it might be different. It might be the same. It might also be different. And we need to understand it and rethink that and not try to squeeze the new into the old. Yeah.
Yeah, which sounds reasonable. So, Ari, let's be futuristic. When can I print my car at Mercedes-Benz, my batch size 1 customized cars at Mercedes?
That's really an interesting question, because that is a vision which I share. I would love to have my first printed car. As we already discussed, I mean, the technology is making giant leaps forward, but there are still various challenges on its way, which needs to be solved. But I'm pretty sure that in near future, you might be able to see as various 3D printed parts in your vehicles, which you drive around on a day-to-day basis. And that would be the first step, going towards a 3D printed car. And we are working on it. We have ideas, we have research going on. So I think it's not very far in the future, but definitely it would take some time until you can just print your car. And the next step will be to print your car at home.
Yes, I'm looking forward to 3D printer. If I can print my car at home, I can ask Carsten when I can print my power generator as well at home. I think so. So, gentlemen, I think it was a great conversation. So we are almost at the end of the show. So I will give you the opportunity for your last famous words. And I would just like to start with Ari. Ari, what is your conclusion, outcome? What do you want to add as your final statement?
So this time made us think a lot and work a lot and do a lot. And what I would request the whole community is, of all the people involved in additive manufacturing and manufacturing as such, is do not lose the momentum which we have gained in this time of crisis. Do not lose the spirit of collaboration, which we have seen has helped us in this crisis, and try and work together to bring additive manufacturing from a niche technology into a mainstream technology and leverage all the benefits of additive manufacturing.
Cool. Carsten?
I agree to most of the points Ari mentioned. While we speak here, additive manufacturing is disrupting the way we produce, we design products, and we do business, like the spare parts supply chain. And the current crisis has shown the big potential. And I really would like to mention as well that this is something that additive manufacturing will be strengthened after the crisis. A lot of companies are rethinking their supply chain, distributed, more localized production, and 3D printing will play a crucial role. At the end, it's a journey. We are not yet there. It's about all the digital tools, about automating complete factories, which serves at a level of qualified costs and productivity. And there we have the same rules like in the classical industry. And at the end of the day, 3D printing will be a coexisting technology next to milling or injection molding technology. And it's all about collaborating. I can urge the community to work together only if we manage it as a big collaborative approach. We will be successful with additive manufacturing in the future.
Well, I think a great statement, and just let me sum up my impression of the talk, even that you're really two smart, cool guys. To me, we have started with ventilators and disruption due to the crisis, and we have seen that people are trusting their life to parts which have been done in a completely new way, collaboration on 3D printing, which was amazing. And now we have a journey towards, let's say, my own 3D printed cars. It will not be done immediately, so we are on a journey, and there's a lot of things I think on the road we have to just check and manage. But I have learned we are much more progressed on this road than you maybe imagine as an outsider if you look inside the industries. And if you have the right partners, if you have the right tools and the right people in the organizations who push the topic and keep the digital transformation and the digital processes to life. Thank you very much. This was Beyond Now. Have a look at the next show. Thanks, Carsten. Thanks, Ari.
Thank you for having us.
Thank you, Mirko, for inviting us. Goodbye.
Bye.